Given any quadratic equation of the form y equals ax squared plus bx plus c, where a, b, and c are real numbers and a does not equal 0, we can find the roots of the equation by the quadratic formula. So we figured out how to find the roots of an equation by factoring, giving us the linear factors, which are also the zeros. We found them by graphing and finding the points that are on the x-axis. So here is a third way to find the roots of a quadratic equation. This formula is really helpful in finding roots that are not exactly whole numbers. Sometimes you're going to find that there are rational roots that are whole numbers or fraction numbers, and sometimes they're going to be irrational roots. Remember, irrational numbers are numbers that go on and on and on without a pattern. So in quadratic equations, there can sometimes be irrational roots. And when that's the case, we're going to be using this equation to find them. So we're going to go through 4 examples, and then you're going to try 4 more on your own using the formula. So taking a look at number 1, we have 2x squared plus x minus 6. So the 2 is our b, the 2 is our a. The 1 in front of the x, the invisible 1, is our b. And the negative 6 is our c. Now, the hardest part about this is making sure that you keep the signs with the numbers and don't mess up your order of operations. So in this case, we have x equals negative b, so negative 1 plus or minus the square root of b squared, so that's 1 squared, minus 4 times a, which is 2, times c, which is negative 6. All over 2a, which is 2 times 2. Then we start to simplify. So x equals, we leave the negative 1 on the outside, plus or minus. And inside the parentheses, we do our exponent first. 1 squared is 1. And then negative times a negative is going to give me a positive, so I'm going to change my sign. Then 4 times 2 is 8, times 6 is 48. All over 2 times 2, which is 4. Bring that down again. X now equals negative 1 plus or minus the square root of 49 divided by 4. Now, in this case, it's pretty easy because the square root of 49 is a whole number. So we can take the square root. X equals negative 1 plus or minus 7 over 4. And now we get 2 answers. X can be equal to negative 1 plus 7, which is 6, divided by 4, which is 3/2. Or x can be equal to negative 1 minus 7, which is negative 8, divided by 4, which is negative 2. So our roots are 3/2 or 1.5 and negative 2. And these are rational roots because they both can be expressed as fractions. Number 2, we go through the same process again. In this case, our a is 1, our b is 2, and our c is negative 1. We start by substituting it in. X equals negative b, so that's negative 2 plus or minus the square root of b squared is going to be 2 squared minus 4 times a, which is 1, times c, which is negative 1. All over 2 times a, which is 2 times 1. Now we start to simplify. X equals, bring down the negative 2, bring down the plus or minus. The square root of 2 squared is 4. A negative times a negative makes a positive, and 4 times 1 times 1 is just 4. All over 2 times 1 is 2. We continue to simplify. Negative 2 plus or minus the square root of 8 all over 2. Now, square root of 8 cannot be broken down to a whole number because 8 is not a perfect square. But within 8, we have a perfect square factor of 4. And the square root of 4 is 2. So we can simplify the radical as x equals negative 2 plus or minus 2 radical 2. Because remember, 8 was 4 times 2. The 2 stays under the radical because it's not a perfect square. and the square root of 4 is 2. That comes out of the radical, all over 2. We can take one more step and simplify this a little bit further. X equals, since both parts of the numerator are divisible by 2, I can divide both parts by 2. Negative 2 divided by 2 is negative 1, plus or minus 2 divided by 2 is 1, so I'm just left with square root 2. Since I'm left with the square root, I no longer have rational roots, I have irrational roots. Taking a look at number 3, we go through the same process again. This time we have A is 1, B is negative 7, and C is positive 6. We start by substituting it in. X equals negative B, which is negative 7. So a negative times a negative is going to make it positive 7, plus or minus the square root of B squared, a negative 7 squared. So that's going to give me 49. And if you want to do that square right away, that's fine. Minus 4 times A, which is 1, times C, which is 6, all over 2A, which is 2 times 1. Simplifying, 7 plus or minus the square root of 49 minus 4 times 1 times 6 is 24, all over 2. So X equals 7 plus or minus the square root of 25 divided by 2. In this case, right away, just from this point, I can tell that I'm going to have rational roots because the square root of 25 is easily done. Square root of 25 is 5, so we get 7 plus or minus 5 divided by 2. So X can be two things. It can be 7 plus 5 divided by 2, which is 12 divided by 2, which is 6, or 7 minus 5 divided by 2, which is 2 divided by 2, or 1. So the roots in this case are 6 and 1. And if you remember, if you look back up to that one is easily factorable. So you can use the quadratic formula, or you can factor it, or you can complete the square to solve for what x would be if y was 0, which again is called the roots, or the linear factors, or the zeros. So one last example with you. Again, we have A is 1, B is 2, and C is negative 4. We start by plugging it in. Negative B would be negative 2 plus or minus the square root of B squared, which is 2 times 2 or 4, minus 4 times 1 times negative 4. Really important to make sure you're including the signs there. All divided by 2A, which is 2 times 1. Bring it down, x equals negative 2 plus or minus the square root of 4 minus a negative, actually 4 minus, I'm going to actually change that to plus because it's a negative times a negative, so 4 plus. 4 times 1 times 4 is going to be 16, all over 2. Bring that down, x equals negative 2, make sure you hold on to that negative sign, plus or minus the square root of 20 divided by 2. Now, right away, just from this point, I can tell that this is going to be irrational roots because 20 is not a perfect square, so we have to simplify that. 20 is 4 times 5. I can take the square root of the 4, so that's going to come out of the radical, and the 5 is going to stay under the radical. So x equals negative 2 plus or minus square root of 4 is 2, leaving the 5 under the radical, all divided by 2. And just like before, negative 2 and positive 2 are divided by 2, so I can simplify this to x equals negative 1 plus or minus the square root of 5. Can't go any further than that, though, because negative 1 and square root 5 are not like terms. They cannot be put together. So our final answer is just that, negative 1 plus or minus the square root of 5, which is irrational roots. So So you're going to try the next 4, making sure you simplify all the way, making sure the equation is written in standard form first if it's not already for you, and answer the questions on the Go Formative as you go.